Hello everyone, we are Team RunTime and our project for today is a refreshable Braille pad. In the United States, over 12 million have vision impairment, with around 1 million of them being completely blind. The CDC approximates that this number will nearly double by the year 2050. One of the major drawbacks of existing and traditional Braille materials are the paper space requirements and the bulk of Braille books, the limited and slower scanning strategies for accessing information, and difficulties with tools for reading and writing, which has raised concerns over literacy for blind people in the United States. Currently, the price of Braille displays range from $3,000 to $15,000 depending on the number of Braille characters displayed. By Braille displays, we mean refreshable Braille pads, which are smaller alternatives to large Braille books. We aim to solve this problem by providing a low-cost and easily accessible alternative to this. Our project involves a 3D printed enclosure with pins that vibrate in a pattern corresponding to the Braille for the alphabet or word that is being read. By being read, we are taking an image or a scanned piece of text, running that through a conversion that then gives us the corresponding Braille. Braille works in two forms, in a 6 and an 8 grid array. We have opted to go for the 8 grid array as it is more complex and provides access to a greater number of characters, thus improving the learning rate. We have also added in a similar grid of LEDs as it is difficult to demonstrate the vibration of the pins in this video. You can see the LEDs light up corresponding to the Braille pattern. The article being read out is actually a survey of Facebook research that states, in this section, we summarize the themes and findings of research that emerged from our review of the literature. You can pause this video and compare what I have just said to the Braille text we are putting up on screen. You can see how a device like this can provide access to even complex research articles and assist the visually impaired. Now on to some of the challenges we've faced, starting with the image and character recognition. The biggest problem that we ran into was when the background is a colored pattern. Our characters were not recognized correctly, leading to inconsistencies in the Braille pattern displayed. Another one of the major challenges was 3D printing the actual enclosure. Our initial idea was to have the pins move up and down, much like existing refreshable Braille displays. However, with inconsistencies in 3D printing, this idea was modified to be vibrating pins. We believe this is a trivial problem, as on scale with 3D printers that have been well calibrated, this issue can be easily solved. After all, RunTime strongly believes that the world only progresses when nobody is left behind, and we aim to do just that. Thank you for your consideration and your time.